Black holes, the mysterious invisible objects in space that warp time and space itself. They've fascinated scientists and the public alike for centuries. But despite their intriguing nature, there's still a lot about them we don't understand. One of the most puzzling questions is, are black holes hot or cold? To answer this question, we need to dive deep into both the science of black holes and the science of temperature. What is temperature anyway? It's not just about how hot something feels, like when you touch a stove or a cup of coffee. Temperature, on the fundamental level, is a measure of the motion of particles. The faster they move, the hotter something is. So, let's begin by understanding what a black hole really is. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. The boundary of this region is called the event horizon, and beyond it we know very little. But despite the mystery, one thing is clear. Black holes can have a very strange relationship with temperature. Before we get to the temperature of black holes, let's first talk about temperature in space. In space, the temperature of objects can vary drastically. Take, for example, stars. Stars like our sun are incredibly hot, with surface temperatures reaching thousands of degrees Celsius. But space itself, the empty vacuum between stars and galaxies, is incredibly cold, at about 2.7 Kelvin. That's minus 270 degrees Celsius. Now, the key thing to understand about black holes is that they aren't just black because they suck in light. They also possess an interesting phenomenon at their event horizon that leads to them having a temperature of their own. In 1974, physicist Stephen Hawking made a groundbreaking discovery. He showed that black holes actually emit radiation that we now call Hawking radiation. Hawking radiation arises because of quantum effects near the event horizon. In quantum mechanics, there are always fluctuations in energy even in empty space. Near a black hole's event horizon, these fluctuations can create pairs of particles, one with positive energy and one with negative energy. Normally, these particles annihilate each other almost instantly, but near a black hole, one of them can fall into the black hole while the other escapes. The particle that escapes carries away energy, and this escaping energy is what we perceive as Hawking radiation. The energy of this radiation depends on the size of the black hole. In fact, the smaller the black hole, the hotter it gets. And because the radiation is made up of particles, this gives black holes an effective temperature. But here's where it gets interesting. Black holes come in all sizes. The more massive a black hole is, the cooler it is. This is because, although smaller black holes emit more radiation, they also have smaller event horizons. Large black holes, like the supermassive ones found at the centers of galaxies, have huge event horizons and emit very little Hawking radiation, making them effectively very cold. Let's put this into perspective. A stellar mass black hole, with a mass about 10 times that of our sun, has a temperature of around 10 to the power of negative 8 Kelvin, incredibly cold. In contrast, a supermassive black hole, with a mass of millions or billions of times the mass of our sun, might only have a temperature of around 10 to the power of negative 10 Kelvin, even colder. So, in a sense, the bigger the black hole, the colder it is. In fact, the temperature of even the smallest black holes is so low that it's almost impossible to detect the radiation they emit with current technology. Now, you might be thinking, okay, so black holes are cold, but isn't there a chance that they could be hot in some way? The answer is yes, but not in the way we normally think about heat. The key thing to remember here is that black holes themselves, as defined by their event horizons, are not hot in the conventional sense. It's the radiation they emit, the Hawking radiation, that gives them their temperature. So, to answer the question, are black holes hot or cold? It depends on the size of the black hole. Stellar mass black holes are incredibly cold, while small black holes can be hot. But on a cosmic scale, most black holes are quite cold due to their large mass and massive event horizons. The fascinating thing about black holes is that their temperature is one of the few measurable properties we can use to study them. And as our technology advances, we may one day be able to directly detect the Hawking radiation from black holes, but until then, this mystery remains just one of the many ways black holes continue to baffle and amaze scientists. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more content on the mysteries of space. Until next time, keep exploring the universe.